Alright, hey guys, so this video is about two-story problems that are on part of your review that I gave you guys. So it's like the last page of the review. So we've got this little problem about a little woodland jumping mouse. It says it can hop a surprisingly long distance given its small size. A relatively long hop can be modeled by the equation y equals negative 2/9x, then in parentheses x minus 6, where x and y are measured in feet. How far can the woodland jumping mouse hop, and how high can it hop? Okay, so anytime you're given a story problem with a quadratic here, what you need to do is first identify what form is that quadratic equation written in. So the first thing that I look at is how many x's I have. And in this one, it's a little bit more unique because there's two x's, and there's only one form of a quadratic equation that has, well, okay, let me take that, sorry. One of the defining characteristics of one of the types is that it has two x's that aren't raised to any powers, and we also have parentheses, and that's factored form. So I know it's factored form because I have the two x's, I have parentheses, I have nothing squared. That's kind of what makes factored form, okay? So once you've identified what form it's written in, then you need to think about what does factored form tell you? Like, what are its obvious reasons for existing, kind of? And the reason that we have factored form and we use it is it gives you the roots of the equation, and the roots are your x-intercepts. So I know, just kind of like looking at my little graph over here, somehow that equation gives me that value right there, and it gives me that value over, I kind of missed there, let me try that again. Over here, I still missed. Whatever, you guys get my point, right there. Oh, there we go, okay. So, I know that this first one is going to be a 0. Okay, it's kind of obvious, but I also know that, so I'm going to kind of rewrite my equation over here. So I know that it's at 0 specifically because when I rewrite this in like true factored form where I show both zeros, I have literally a 0 either being added or subtracted that x, but we just don't write the 0. It's not necessary. It's just, it makes the equation more messy. Okay, so we leave that 0 out, but it's still technically there, and it represents that point that I just drew on there. Okay, so the other one that I know factor form gives me is it gives me the 6 over here. So by logic, this is 6, right? It's my other root. Okay, and it's positive 6 because remember in parentheses it's always opposite of what you think it should be when we're dealing with a graph. Okay, so I am not even like looking yet at what the question's even asking me to find. I'm just taking what I know about factored form, I'm applying it to my graph and just kind of labeling things. Okay, so the other thing that I know that I can find based off the information that I have is I can find where my vertex is going to be, and the vertex is always going to be at the highest point, and I know that quadratic functions are symmetrical, and so if from 0 to 6 is the whole length, I know in the middle is going to be 3. Okay, it's half a 6. Alright. Well, and also I've only found half of my vertex, right? So what I need to do then is I need to, if the x value is 3, I need to plug that into my equation. So, got to do with my parentheses, so that's a negative, there we go. Alright, so I've got that, so now I'm going to multiply, and when multiplication, really, you can kind of do it in any order. So I'm going to multiply my 3 and negative 3 to get my negative 9 there, and then I need to multiply that by negative 2/9. When I multiply fractions, I multiply straight across, I'm going to turn that into a fraction. So I get negative, oops, sorry, not negative. Negative 2 times negative 9 is positive 18. 9 times 1 is 9, so 18 over 9 is 2. Okay? Alright, so that means that my height here of my vertex is at 2. So my vertex is at 2, 3. Alright, so I found all of that without even looking at what it asked me. Okay, and maybe I found more than I needed to, but I kind of doubt it just because I know the equation. So, going back to what the question was asking me, it said, how far can a woodland jumping mouse hop? Okay, so how far can it go? So, from where it starts to where it ends. So, how far did it jump? It jumped 6 feet. And I know that because literally that's the length from here to here, right? Okay, so the first answer is 6 feet. That's how far he jumped, okay? Okay, so then I need to look for, it said how high can it hop? So the highest point that it jumps was at my vertex, and oops, and I just realized I have an error in what I wrote here. It's not 2, 3, it's 3, 2. My bad, sorry. Okay, got that fixed. Alright, so but how high he can jump, we know that at 3 feet, he jumped 2 feet high. So the 2 feet, right here, that's how high he jumped. That's it. Okay. So this next one, we've got the Golden Gate Bridge in San Francisco has 2 towers that rise 500 feet above the road and are connected by suspension cables as shown. Each cable forms a parabola with equation, all of that, where x and y are measured in feet. And we want to know what the distance d between the towers, 2 towers is, and what's the height L above the road of a cable at its lowest point. Alright, and it kind of labels here, we want to find d and we want to find L. Alright, but again, before I really get caught up in what it's asking me, I want to identify what kind of an equation is given to me and what is that going to help me find. Okay, so when I look at that equation, I see that I have one set of parentheses and I see that it's squared. That means that it is in vertex form. Okay. In fact, now that I'm thinking about it, I'm going to go back up and write factored up here for you guys. Okay. So it's in vertex form. So the vertex form gives me the vertex. So I'm gonna label that before I forget, okay? So on my vertex, which would be right here on the graph, approximately, it's gonna involve that number and that number. This is the x value of it, and that's the y value of it. So right here, I'm gonna have 2, 1, 0, 0, comma, 8. Alright? So, it's my vertex. And just like in the problem above, if I know the vertex, that is the center of the graph, which means I can have that help me find how long it is. So, if I know the center is at 2,100, that means over here, if we count and see their labels, that's the y-axis over here. So that means that this is at 0, and I want to find that whole length. So if the middle is at 2,100, that means over here it is at, oops, that's a horrible written for. It's at 4,200. Okay, you just double it. Because, again, vertex is in half. You take that x value and double it to find your whole length along the x-axis. Alright. So I've got kind of some key pieces of information. So I'm going to go to my questions. What is the distance d between the 2 towers? That's what I just found. That is the answer to A. Okay. It says what is the height L above the above the road of a cable at its lowest point. So, and it even draws right here. So that L, I need to find that distance between there. And remembering that this is the x-axis right there, the distance between there up to the parabola is going to be the y value of the vertex. Okay, because that point that is on there is the vertex, so the distance is just 8. So it's 8 feet above. Ta-da!